Hello, my name is Tianyu Shi, and I'm a research engineer at Nethermind. I'm also a mentor of ETHGlobal Singapore, and I'm glad to be here to give you an overview video about the Nethermind Bounty. Nethermind is a blockchain research and engineering company. Nowadays, we put more focus on AI and robots. So today's topic, or today's bounty's topic, is about AI and blockchain data. The theme of this bounty is to explore the synergy between artificial intelligence and blockchain data to unlock their full potential. Before delving into their potential parts, let's answer one simple question. Why apply AI in blockchain data? Here are three features I summarized below for your understanding. Immutable and transparent. Blockchain data is permanently recorded and accessible, offering reliable data sets for AI analysis and training. It is also decentralized and secure. This distributed nature of blockchain ensures data integrity and minimizes tampering, and which is ideal for secure AI applications. And the third is rich transaction history. The abundant data of transaction history is beneficial for AI to identify patterns, trends, and anomalies. So I'd like to introduce the bounty expectations. Different with ordinary bounties, we encourage the use of any development techniques, tools, or methods. It means we do not limit your innovation. Please feel free to explore any meaningful AI approaches that intersect with blockchain data. So far so good. But I guess some of you are wondering what exactly meaningful AI approaches are, and I'd like to give you some examples. Note, these are only illustrative examples, which are simple to grasp, but we do encourage the possibilities, the innovations go way more beyond this. The first one I'd like to introduce, the first scenario I'd like to describe is SIBO attack identification in airdrops. Airdrops in blockchain are vulnerable to SIBO attacks, where malicious actors create multiple fake identities to exploit rewards, compromising fairness and security. And we'd like to come up with AI methods to solve it. And the naive idea is to design some AI detection method. These AI models can analyze blockchain data patterns, such as transaction histories and network behaviors, to identify suspicious activities indicative of SIBO attacks. And one example approach is to detect SIBOs by analyzing asset transfer graphs and refining clusters with k-means mathematical models. It then focuses on behavior patterns like similar contract interactions and transaction timing. In simple words, if 10 different accounts transfer same amount of the money to one smart contract at approximately same time, it is highly indicates that these 10 accounts are controlled by one SIBO user behind them. Autonomous on-chain agents is another good application scenario. Automating on-chain activities often lacks transparency and accountability, as most actions are executed off-chain, reducing traceability and security. And we'd like to leverage the blockchain nature and AI-powered agents to resolve this problem. Autonomous on-chain agents can perform tasks such as trading, governance, voting, and asset management directly on-chain, with every action recorded in real time. One example approach about AI agents which is to execute and log each operation on-chain. It creates an immutable record of decisions and interactions, and this boosts transparency, auditability, and reduce risks of off-chain decision-making. The first example of SIBO identification is to leverage the AI-powered to analyze the blockchain data, and this instance is to introduce the blockchain immutable nature to secure the AI agents, to secure the AI applications. You can see the synergy between these two emergent fields. The next I'm going to introduce is social graph inference and recommendation. Recently, most of blockchain transactions are viewed purely as financial data, overlooking their social relationships embedded with these interactions. So we can borrow some Web2 common social graph inference to this scenario as well. Treating transactions as nodes and edges in a social graph allows AI to infer user connections, identify key influencers, and suggest potential interactions. One example approach, which is adopted by some startups, they introduce the graph neural networks, and these neural networks data structure is especially aligned, is especially useful to analyze the user transaction patterns, recommend new DeFi protocols, and finally, the entire models can detect communities and enhance personalized marketing strategies based on the inferred social connections. So this is another example of leveraging the AI power to exploit the useful insights from the blockchain data. The last one I'm going to give you hints is about AI smart contract auditor. Smart contracts are susceptible to vulnerabilities and coding errors, leading to financial losses, security breaches, and exploitation by malicious actors. So we are considering how we can leverage the AI to autonomously audit the smart contracts or to increase the auditing efficiency. So AI-driven tools can analyze smart contract code to detect their vulnerabilities, logic errors, and security flaws more efficiently than traditional manual audits. And because of the emerging large language models, we trained LLMs on extensive data sets of smart contract code, non-exploits, and some other security practice. After the training, these specified large language models can identify complex vulnerabilities and offers real-time auditing to enhance the security and reliability of smart contracts. I'd like to show you an AI code auditor. It is a work in progress by Nethermind. I wish it can give you more development instance or ideas about what we expect for. As you can see here, it is the interface, and let's try the example one first. After the loading, yeah, sounds good. After the loading, we can find that there's a bad randomness vulnerability at line 8 in the first example. It refers to the issue related to the generation of the random numbers in simple words, like if the random numbers in the smart contract can be predicted, it definitely leads to some unfair outcomes or exploitation by attackers. And after seeing the first example, let's try the example 4 to give you more insights. Okay. There is another error called unchecked low-level calls in this example 4. It means that the return value of low-level codes is not checked in this smart contract, which potentially leads to the unexpected behavior or security vulnerabilities which cannot be predicted, but it's very important to avoid, or it's not allowed to exist in a safe and secure smart contract. Okay, let's see the final example, smart contract 5. There are two vulnerabilities in the example 5. The first one is the reentrancy vulnerability. It is a very common but very significant flaw in the smart contract because it allows attackers repeatedly call back into the calling contract before the initial execution is complete. So it finally results in inconsistent state or theft of funds. And another one is denial of service. It means that the contract will become responsible, will become unresponsible to some legit users. So it causes some like the function flaw as well. So that's good. I wish these small work in progress can give you more insights about what we expect, how we can leverage the AI in blockchain data. So let's come back to the slides. Okay, let's pivot to the bounty evaluation. There remain three main criteria to evaluate the submitted project. The first one is undoubtedly the originality and creativity in leveraging the artificial intelligence and blockchain data. And we also want to emphasize the comprehensiveness and technical soundness of the project's functionality. In other words, we'd like to see more meaningful AI applications, instead of some, instead of some copy paste from Web2 applications. And the last one is the overall quality of the final implementation. It's almost the end of my presentation, but I'd like to emphasize that don't worry not being perfect enough, or if you have any questions, never mind. And we are always here to offer you assistance to answer your questions and to resolve your problems. We look forward your innovations in these two emerging fields, including the AI and blockchain, and let's push the boundary of them.
Hey guys, my name is Ayush and I work as a DevRel at Nethermind. And I'm going to tell you about the Nethermind bounty and also tell you about Starknet and why Starknet is a game changer in the blockchain space and why you should explore it being in Web3. To understand why Starknet is exciting, let us first examine Ethereum's core scaling challenges. So that would be like the block size, time constraint. So with a 12-second block time and gas limit, there's a cap on how many transactions that can be processed on-chain. Then comes the state growth. As more transactions modify Ethereum's global state, it becomes increasingly resource intensive for nodes to manage. Then comes the consensus overhead. In Ethereum, all full nodes must process every transaction to reach an agreement. This universal validation requirement fundamentally limits the scalability for L1. Then comes the data availability costs. Storing all transaction data on-chain is really expensive, and this leads to rapid chain growth. These factors together combine to create a network congestion and high gas fees on L1, especially during peak usage of the network. This is where layer 2 solutions like Starknet come into the picture. They address these challenges in 4 key ways. First is increased throughput. Layer 2s process more transactions per second by moving operations off-chain. Second is reduced cost. They lower fees of the transactions by batching multiple transactions into one L1 interaction. Third comes the maintained security. Layer 2s inherit Ethereum's security through cryptographic proof generation, which in case of Starknet is specifically called a validity proof. Finally, and perhaps the most exciting one, is that they enable us to do complex computation on-chain. This means we can now run resource-intensive operations cheaply, opening up entirely new blockchain use cases, which still needs to be explored. So Starknet as a ZK rollup takes these benefits even further. ZK stands for zero knowledge, a cryptographic method that allows one party to prove another that a statement is true without revealing any information beyond the validity of the statement itself. In Starknet's case, this means that we can prove that a batch of transactions is valid without processing each transaction individually on Ethereum. This achieves greater scalability while maintaining security, enabling a new class of blockchain applications which were previously infeasible due to cost or computational constraints on Ethereum. So, Starknet brings ZK rollups to life using Starks, which is scalable transparent argument of knowledge. Here's how it works actually. So, Starknet represents its entire state using a Merkle-Patricia tree, processing transactions off-chain to update this state. It then generates a Stark proof, a cryptographic guarantee that these updates are valid. This proof, along with the compact state commitment, is sent to the Ethereum for verification. The beauty of this system is its efficiency. A single proof can validate thousands of transactions, which dramatically reduces the data footprint on Ethereum. This allows Starknet to achieve throughput and lower cost while inheriting Ethereum's robust security features. By moving complex computations off-chain but anchoring the results on Ethereum, Starknet opens up a new possibility for blockchain applications. It's not just about scaling existing use cases which are present on different layers already, but it's about enabling entirely new ones that were previously impractical due to cost or performance constraints. Now, let us dig a little bit more on how Starknet is classified. So, Starknet is classified as a Type 4 ZK EVM. It means it's optimized for efficiency rather than exact Ethereum equivalence. It's like we are reimagining what's possible with blockchain computation. This approach was crucial for scaling Ethereum because it allows for greater optimization and efficiency. By moving away from the strict EVM equivalence, Starknet can leverage custom built systems that are specifically designed for generating zero knowledge proofs. The trade off is slightly different developer experience compared to how you do things on Ethereum. However, this sacrifice in immediate familiarity enables us to push boundaries of what's possible on the blockchain. We can perform more complex computation, handle larger data sets, and create more sophisticated smart contracts in Cairo, which is the programming language for Starknet, smart contracts, all while maintaining the security guarantees of Ethereum. And this is why Type 4 is so exciting. It's not about making Ethereum faster or cheaper, but about fundamentally expanding the capabilities of blockchain technology. Let me quickly walk you through Starknet's transaction lifecycle. It's a bit technical, but understanding this process is key to appreciating Starknet's efficiency. So the first step is transaction submission. A transaction is sent to a gateway, entering the mempool with a received status. The mempool is like a waiting room for transactions, holding them until they are ready to being processed. Then comes the mempool validation step. The mempool performs initial checks like ensuring sufficient balance for fees. This is similar to Ethereum's signature checking, but Starknet adds custom validation functions for different transaction types. Then comes the step 3, which is sequencer validation. The sequencer revalidates transactions before execution, ensuring they are still valid in the current state. The fourth step is execution. Valid transactions are applied to the state. Failed transactions are included as reverted. The next step would be proof generation and verification. This is where Starknet's magic happens. The prover generates a cryptographic proof for the entire block's execution, which is then verified on Ethereum L1. This process allows Starknet to batch thousands of transactions into a single proof, significantly reducing costs and increasing throughput while maintaining Ethereum security. It is this efficient proof system that enables more complex computations possible on Starknet. One of Starknet's unique feature is its built-in account abstraction. Unlike Ethereum's EOAs, which are externally owned accounts, all accounts on Starknet are smart contracts. This enables signature abstraction, which means that you can customize how your account validates transactions. Then potential for fee abstraction, which means that we can pay gas fees in different ERC20 tokens. Then comes nonce abstraction, which helps us to send multiple transactions in parallel. So this account abstraction built-in feature in Starknet opens up possibilities for various applications like social recovery wallets or biometrically authenticated wallets for your dApp. So Starknet uses a programming language called Cairo. Now the question comes, why do we have to learn Cairo? Why a different language? So Let me introduce you to the features of Cairo. It's a language which is designed specifically for creating efficient ZK proofs, which is the key to Starknet's performance. Cairo allows developers to write complex logic that can be efficiently proven, enabling complex computation that were previously infeasible on chain. You can do all these things just by writing smart contracts in Cairo. You don't have to create any more circuits or anything like that for creating ZK proofs. Now, if we talk about how you can dive in and start learning, we have got a range of resources to suit different learning styles and experience level. First, there's an official Starknet documentation. It is your go-to place for up-to-date guides and references for anything related to Starknet. It can help you start by setting up your environment, then declaring your smart contracts, creating an account, deploying your smart contracts, and then also interacting with them. You can deep dive into the architecture section to understand how Starknet works from an architectural point of view. For our deep dive into Cairo itself, you can use the Cairo book. It's a comprehensive guide that takes you through the language step by step to create provable programs on Starknet as smart contracts, or even a standalone provable program is possible to be written in Cairo. So this would be the go-to place to learn Cairo from very basics. For people who actually like the hands-on approach for learning any language, I would suggest using Starklinks, where you can understand how smart contracts work on Starknet by going through all these exercises and compiling them, and also seeing if things work the way you think they are working. Other than that, we also have Cairo on Exorcism, which can help you learn Cairo. For those who enjoy a more gamified experience for learning anything, Node Guardians would be the best place because they provide challenges and quests to level up your Starknet skills. We also have a crash course on Starknet, which is a list of various resources that you would use during your application building on Starknet. So I would walk you through all the resources that I mentioned here. First would be the OpenRPC Playground. This would help you understand what are different methods that you can call from a Starknet node API. For example, like the Starknet spec version, which returns the version of the Starknet JSON RPC specification which is being used. Now, the question comes, how do you create these code snippets? If that is also something which you want from us, then you can go on to the crash course page and then migrate to the Starknet JSON RPC builder. This is where you can request for code snippets for interaction to Starknet using Starknet.js or Starknet Go or Starknet.rs. For example, I'll walk you through a request which we can create here. To get started here, I would need an API key that I can get from Voyager, which is the blockchain explorer for Starknet. Now we can go to access Starknet RPC, get started for free. And here you need to create your own RPC API key. I'll name it as demo. Then we can copy this API key and go back to the JSON RPC builder, this one, and paste the API key here. Now I want to call this particular function Starknet spec version, and I can just click on send request. You can see I get a response here saying that the spec version right now is 0.7.1. You can copy code snippets from here if you're using Starknet.js. If you're using Starknet.go, you can migrate here. You will get all the code snippets which are required for creating applications on Starknet. In the crash course, you can also see that we have an introduction to Juno, which is basically a Go implementation of a Starknet full node client, which is created by Nethermind. This would allow node operators to easily and reliably support the network. You can create your own Juno instance on a system, and you can use that for putting the RPC request that you're creating in this JSON RPC builder. Apart from that, these are the things which you can also use, like the Starknet CLI, then Starknet architecture documentation, which is also present in the Starknet documentation, then the Cairo book, and this is the bridge that you can use for Ethereum to Starknet. So basically this bridge helps you migrate your assets from Ethereum L1 to Starknet within 3 minutes, but a migration from Starknet to Ethereum L1 can take a maximum up to 7 hours. Then here are some links to the major dApps documentation which are present on Starknet. Ikubo is the largest AMM present on Starknet right now, and largest transaction router is Avenue. So you can use these dApp documentations to build something on top of them as well. Then here's the link for the Starknet ecosystem. You can go to this to explore all other community driven resources that are present for Starknet. Whether you are a beginner or an experienced dev looking to expand your blockchain skills, all these resources will help you get up to speed with Starknet and Cairo. We have plenty of resources apart from these which are driven by community as well. But to get the link of all these resources, you can scan this QR code. Now, here comes the most awaited part, the discussion about the Starknet.anything bounty. We are offering a prize pool of $1,000 for the most innovative project that can be built on Starknet. So Starknet's architecture allows for some interesting capabilities that weren't feasible before on-chain. So we have some ideas of what you could build around. So things like DeFi, AI, verifiable compute, privacy, cross-chain applications, or games. But honestly, these are just suggestions. What we are really interested is in seeing what you come up with. Maybe it's something even we haven't thought of yet. That's the coolest thing about new tech, right? Sometimes the best ideas come from fresh perspectives or hackathons like ETH Online. The qualification requirement for Starknet.anything bounty are pretty simple. The project source code must be hosted on a code repository like GitHub. The code must be your own work, and you must demonstrate that your project is executable on Starknet testnet and is working fine completely there. We are not expecting you to revolutionize the blockchain overnight. We are just curious to see what kind of creative solutions you can build using Starknet's features. So give it some thought. We are excited to see what you'll create. Remember, the goal isn't to make existing applications cheaper or migrating applications from different blockchains to Starknet. It's to imagine and build things that weren't possible before. So if you have any idea that you think could work very well on Starknet, we would love to see it. Don't worry about being perfect or world changing. We are here to help you for whatever need you have or whatever doubts you get. So good luck, and let's push the boundaries with Starknet.
What's up, everybody? I'm John Church, a product manager at Nethermind, and I'm going to be talking about the MEV infrastructure bounty. We're supporting a Starknet MEV infrastructure bounty because Starknet needs MEV infrastructure, and especially as Starknet moves towards a decentralized ecosystem. And we think that helping people get involved with some of the different bounties and building products and ideas in the MEV infrastructure space will help Starknet's ecosystem be more healthy and have healthier markets. Real quick, high level, what is MEV? It's called maximal extractable value. Originally, it was minor extractable value. This term has changed over time, but it roughly refers to the value that a miner, validator, block producer can extract from manipulating or managing or messing with the order, inclusion, exclusion of blocks. And transactions within a block. MEV can be positive, MEV can be negative, and that's why this is an MEV infrastructure bounty, which is we want to help dApps and the larger ecosystem make MEV a neutral or positive force, because when MEV is properly accounted for, properly built, it becomes revenue stream for apps, and it becomes a revenue stream for the larger ecosystem, and ultimately helps make markets more healthy, helps make pricing in the markets like a Kubo and others, makes pricing more accurate and aligned with other marketplaces like Binance, Coinbase, Ethereum, etc. So it's critical for supporting healthy markets, and that's what we really want to enable. Due to Starknet, currently Starknet is a first in, first out, or first come, first serve transaction order flow. So due to that, the MEV is a bit limited in terms of, which is good. This is fine. It's front running, sandwich attacks, etc. are very, very hard to do, and that's great. And that's partially why we wanted to do this as a Starknet infrastructure rather than anything else. So just kind of highlighting that we want this to support healthy markets. Examples of MEV infrastructure: solver markets like CowSwap or Uniswap X. Like, these are some ideas that you can use to think about, what would you like to build? So solver infrastructure examples on L1 or CowSwap, where they created a marketplace for solvers, and user intent. So user intent comes in, I want to swap ETH to USDC or USDC to ETH, and then solvers go find the best routing and best pricing, and then they present that. They take that swap and then they present that to the user. So solver markets dApp infrastructure to integrate MEV. This is something that I think, CowSwap specifically created the UI and then the solver infrastructure. I think that there's opportunities in terms of creating solver infrastructure that is UI agnostic. And so you can plug into different dApps, or dApps could use that, maybe like an SDK or libraries. I think there's a lot of opportunities there. Also generating intent markets. And this is kind of an adjunct to the previous example of the dApp infrastructure to integrate MEV, generating a marketplace where solvers can compete, where user intents come in. And then ultimately, I think exploring this space is a big opportunity. Like, this is the MEV infrastructure space is wide open. There's a lot of research, a lot of thought, a lot of novel exploration around different ideas happening in the MEV infrastructure space. How do you aligning MEV to the different layers that they're on, to the dApps that they're on, to the wallets that are being used? I think that there's new and novel ideas are certainly welcome here, and especially MEV in relationship to cryptographic like ZK integration into MEV. I don't think this has been explored yet. I think that there's a lot of opportunity, like proving compute through ZK. I think there's some novel thought and novel products and ideas that can happen there. Just high level requirements for judgment. To be considered, your project source code must be hosted on a repository like GitHub, must be your own work, and you must demonstrate that it's executable on Starknet testnet. So it's got to work. Your project will also be judged on the quality of the cryptography underlying the project. Basically, that like how much do you use the novelty of Starknet and ZK and what's available. Also, the quality of the implementation will be judged, and the amount of work that you've done on this during the event. These are some resources that I think are important, and I'm just going to talk through them really quickly. The Starknet MEV on this iSchool's Starknet MEV repository is a list. There's a number of bot builders, bot templates, and high level information on how does Starknet work, how is it different than L1, and so if you need some quick information on how to get there, that's a great place. Also, the Ethereum docs on MEV, which is just a high level primer on what is MEV, how does it impact L1. I included Anoma as a research resource because Anoma is doing some really interesting work in terms of intents marketplaces, which ultimately capturing intents and moving them into solver networks or searcher networks, I think, or in searcher marketplaces. I think there's a wide open space for unique products. Cairo Lang is, of course, the language of Starknet, so you'll need to know that. And then the crash course in Starknet is a publicly available Notion page for that we've produced to help people get up to speed on Starknet. I think that's about a wrap. Again, I'm John Church. Best of luck out there and get those bounties.